Hello and welcome to this video titled Components of Computer Networks, Servers, NICs, Switches, Routers, and Firewalls. So in this video I'm going to cover what's the difference between servers and clients, what's meant by this term local and remote resources, and then we're going to dive into some common network components you would find in networks today, such as NICs, switches, routers, firewalls, and IPS devices. Let's start out with this terminology of servers and clients. So most of the time when you are on a network with your laptop, smartphone, tablet, PC, your device that you're working on would be considered a client. And the majority of what you do on your network is you reach out to a remote computing device and say, hey, you have some data I want, can you give it to me? So that device which is storing the data for you and lots of other people is considered a server. So you can see here some common clients, like it shows you, are smartphones, laptops, tablets. They all have memory, they all have CPUs that have the intelligence and smarts to run various applications and apps and programs. And certainly you can use your clients offline without the network to do a variety of things. For example, on your laptop, you can certainly open up a text editor and create text notes to yourself. Or you can open up some drawing program and draw graphics for yourself. But most of the time these days, here we are in 2019, most of what people do these days requires them to be on a network and connect to another remote computer and get the resources of that computer. And that's what we call a server. Now a server is very similar to a client in that it has CPU, a central processing unit, which is the brain or intelligence of the device. It's got memory for storing information. Okay? It has a way of connecting to a network, but what makes it different is everything it has is bigger, faster, better than a client. Its brain, its CPU is much, much faster. It can handle a lot more incoming connections and requests. It can handle a lot more simultaneous programs running than a client can. Its memory is much bigger. The quantity of things it can store is a lot more than a client can. So that's what makes servers and clients different from each other. Now there is something in networking called peer-to-peer networking, which is when one client is actually using the network to exchange data with another client. We don't actually find that very much these days, but maybe an example of that would be if your laptop is sending a print job to a printer. Now that could be considered peer-to-peer, but even in that scenario, some people would say, well, technically the printer is a server and you're sending a print job to it. So I guess probably a better form of peer-to-peer networking would be, this probably isn't done as much anymore, but there used to be applications that John could run on his laptop and Sally could run on her laptop, and they could connect to each other and exchange like music files with each other. Peer-to-peer networking in that case. So there'd be no server, they would each be exchanging data with each other's laptops or PCs. But the majority of the time, a client is requesting the services of a server. All right, local and remote resources. So local resources are things that you can use even when you're not connected to a computer network at all. For example, your local hard disk drive. You can't store anything on your laptop or computer if you don't have some sort of a disk drive to do that. Now a lot of devices these days have what's called solid state drives, which means they don't actually have a physical disk that's spinning, that's storing all of your computer information. But either way, you have to have something locally on your tablet, smartphone, laptop to store local information, and a hard disk drive would be a local resource. It's there for you even when you're not connected to a network at all. You've got your own local memory for storing of information. Certainly your keyboard is a local resource. And your DVD-ROM drive, should you have one of those, is a local resource. All these things, no network is needed. But then there's also network resources. For example, networked hard disk drives. So when I'm communicating with a server and I'm saying, hey server, let me put some information on you. I want to put a file on you so that other people can get to that file. Well, now I'm making use of the hard disk drive on that server. That's not local to me. I have to access the network to get to it. So that would be considered a network or a remote resource. We also have network printers, network optical drives connected to network servers, a lot of things. All right, now to actually connect to any kind of a network, you have to have some connector. You have to have some physical component in your smartphone, tablet, laptop that will give you a connection onto the network. And we call that a network interface card. Now, if that network you're connecting to requires a wired connection, we actually need to plug a cable into it, then you'll be able to see some of that network interface card. Now, from your visibility, it might just look like this. It might just be a little hole in the side of your laptop or PC that you plug the cable into. But in reality, when we take a look at that laptop, the network interface card might actually be inside the laptop, and we're only seeing a small little piece of it here when we see this connector jack. And if we actually broke open the plastic on the outside of the laptop, we'd actually see a card that looks something like this in the side of it, which has got all the electrical and electronic components to make sense out of what's coming in and going out of that cable. So that would be a network interface card. Here's an example of one of the ends of a cable. And for most networks that you and I connect to that require a cable, we call those Ethernet networks. And Ethernet networks, connecting to a host anyway, like a laptop or a PC or a server, typically have a certain type of connector which looks like this. That's not the only one. There are other connectors as well. And this connector right here is called an RJ45. RJ is short for registered jack 45. And that RJ45 will plug in to some hole somewhere, some connector in a switch, or maybe the side of your cube or the side of your wall. So that connector would plug in right here into an RJ45 jack, which would then have another cable on the other side of it, which would lead back to a network switch or a router or something like that. Notice there's also something called an RJ11 jack. This is what typically connects to a phone. So back when we had hardwired phones, not IP phones, but an actual hardwired phone, the phone would connect to the RJ11. Different sizes, used for different purposes. Now, Ethernet is not the only form of networking or network interface card. There's also coaxial cable. So for example, if you've got a cable box at your house, or you've got a DVR provided to you from DirecTV or Dish Network or something like that, it probably has a cable coming into it, but the end of that cable is not an RJ45 cable. As a matter of fact, the actual cable itself is different. If we took an Ethernet cable, took a razor blade to it, and opened it up to see what was inside, and then we took one of these things, an RJ45 cable, took a same razor blade and opened that up, we would see that the guts of that cable were totally different from each other. An Ethernet cable, although it looks like one cable when you hold it in your hands, when you open it up, actually has several little wires inside of that cable, all twisted together into pairs. Whereas a coaxial cable is typically just one thick wire inside of it, or maybe sort of a long braid of wire going through it. So used for totally different things. Uses totally different electrical standards to transmit energy and data along these wires. So a coaxial cable will use a completely different type of connector. And you can see an image of that right here. Here on the right, we have a cable modem, which uses a coaxial cable. So this is the connector to it. Okay. Not that you would ever need to know this, but that connector is called an SMA subminiature version A, which you don't really care about. But there's male and female versions, right? So this right here is clearly a female version of that. And here's the male version of the subminiature A connector. So there's the connector on the end of that cable. And then there's the wall plate. So some computer networks travel across coaxial cables. So you would need the appropriate NIC to connect to that. And then of course there are wireless networks where there's no cable whatsoever. So in this particular case, your NIC card, if you can see anything, you might see an antenna sticking out of it, with the vast majority of the NIC right here being hidden from you inside your laptop or your PC. And then that NIC card, you'll actually have a radio, although what we actually call it a transceiver, because it's capable of transmitting information and receiving information, hence transceiver. But most, at least on clients anyway, like laptops, PCs, tablets, and smartphones, most of the time, you won't even be able to physically or visually see if you have a Wi-Fi NIC card. You won't see that because the antenna will actually be built into the device itself. Like on this tablet right here, you don't see the antenna, but when you break it open, this little piece right here, sort of underneath the case, that's the antenna. That's the component that's able to actually transmit the radio frequencies into the air, or receive radio frequencies coming in over the air. But once again, in order to connect to a wireless network, a Wi-Fi network, you need some kind of a Wi-Fi NIC. All right, so those are the ways that we connect to the network. Now, when my host is connecting to the network either via a wired NIC, which has a wire that goes somewhere, or a wireless NIC, which is transmitting radio frequencies, what's on the other end of that? What's on the other end of the wire that's leading from my laptop? Or what's on the other end of the airspace that's receiving my radio frequencies? So that's what we're going to talk about next, which are the infrastructure components, the components that build the network. We call them infrastructure. So most commonly, when you're connected to a wired network, what's on the other end of the wire leading away from your laptop or PC is a network-based switch. And you can see here, they come in different form factors. Some of them are very small, and they might only have 4 or 8 interfaces. We call those ports. So this would be like an 8-port switch. This might be what you would find at your house. Or when you're at a campus or in a large company, you're going to need a switch that might potentially have hundreds of interfaces, like we see right here. And clearly the price between these two guys is going to be vastly different. This little switch right here, you might be able to get for around $150 US. This switch over here is actually a Cisco Nexus 9508 switch. And guess what? This little puppy starts at $50,000 just to buy that. That's without the cards. Each one of these cards you have to pay thousands of dollars extra for. By the time you get it looking like this, you could well be into the hundreds of thousands of dollars. So that is a network-based switch. Now, technically speaking, our network could simply be composed of a bunch of hosts, a bunch of servers, all with cables connecting them, all going into one or more network-based switch. And we could have cables connecting the switches together. We could certainly do that. And a lot of companies do that. But then somebody else came out with another device. They said, hey, we should have a device that has other types of interfaces as well. Like right here, we're just looking at these RJ45 connectors, which is your common connector for an Ethernet cable. But what if I wanted a device that had connectors for both RJ45 and cable, like we just saw with the coaxial cable, or other things? There's literally dozens of different types of cables and connectors which can be used to connect up various different things. You're typically not going to find a switch that's got a wide variety of ports on it like that. So let's create a device that has different types of ports. And while we're at it, why don't we give that device other capabilities that maybe a network-based switch can't have? Other features and things it can do to make security easier, to segment the network, to maybe speed it up or optimize it. And that thing we're talking about is a router. So in some ways, a router might physically look like a switch. Like in this case, this router, it looks like every single interface he has is an RJ45 interface. So although they're kind of spread out and there's some spaces between them, if I gave you this and a switch and I said, which one is the switch? Which one is the router? You might not really be able to tell by looking at this. But inside, the functionality of what this thing can do is the same as a switch in some regards, but also has a lot of things it can do that a switch can never do, that we've talked about, like optimizing the network, prioritizing certain types of traffic over other types of traffic, and a lot of other things too. Like for example, if we take a look at this router right here, notice that right here we have some screws, right? This is actually a removable module. Now in this particular graphic, that module is holding an RJ45 connector, or it's got 4 of them, but we could remove that and put some other type of modular connector in there that's got coaxial cable interfaces, or maybe a little Wi-Fi NIC card in there, or all sorts of other things. So that is a router. Moving on, we also have other components called firewalls and intrusion prevention systems. So let's just real quickly, what do these things do? Well, if I have, let's say, a host and a server here, connected to a switch. Now this could easily also be a router. So by default, either one of these guys, the host or the server, can send information back and forth to each other. There's really no restrictions until I configure some restrictions. So if I have a switch or router, this is really optimized, both of these devices are really optimized for just getting data from the source to the destination as quickly as possible. But what if I say, hey, what if I have something like this? What if this device connected out to the internet, let's say? Well, once again, if this was a router or a switch, by default, not only could my server or my client send data to the internet, initiate a connection to INE.com or initiate a connection to Google.com, but the internet could initiate a connection back to me without me even expecting it. That gets a little bit scary because the internet's got billions and billions of unknown devices in it. A lot of those devices are controlled by people who don't have the same ethics and moral principles that you might have, and they might want to send data into your network with malicious intent to try to crash your devices, take over your devices, steal information from us. So wouldn't it be nice if instead we could have a device that maybe sits right here, let's make this green circle that, and maybe this device said, hey look, when something, and we'll divide the network into two sections, maybe the inside, that's an inside network, and maybe this is the outside network. And what this device is, the logic it worked was that it said, hey, if a device on the inside is initiating a connection to the outside, that's okay. We'll allow that. We'll allow that initiation, and then whoever's on the outside can respond to that. That's okay. But if a device on the outside is trying to initiate a connection, no, not going to allow that. The internet cannot initiate a connection. All it can do is respond to a connection from the inside. Well, this is the basic principle of what a firewall does. A firewall is a way of segmenting your network, whether it be your inside network and the internet, or maybe you have a firewall within your own company and saying, okay, I'm going to segment it, and this interface on the firewall leads off to maybe the west wing of my company. This interface leads off to the east wing. This interface goes to the north wing of my company. And then the firewall has rules in place that says, okay, when data comes in, it's allowed to go out that interface, but not this one. Or when data comes in, we'll allow it to go in. If it comes in the east wing, it can go out to the west wing, and the west wing can respond to that, but the west wing is not allowed to initiate a connection to the east wing. The west wing can initiate a connection northbound, but not this way. That's what a firewall does. It controls the flow of information to make your network more secure. Hence, that's why we call it a firewall. Now, when it comes to firewalls, firewalls have very greatly evolved over time. So originally there was something called traditional firewalls. And so what traditional firewalls did is they made the determination based on their determination of, should I allow this data to go through me or should I drop it and kill it? They basically made it based on the address of that information, where that information was coming from, where it was going to. So all information that you put onto a network has to be addressed in some way. Your laptop, PC, tablet, smartphone, it has a network address. It actually probably has more than one network address, which it uses as a source when it's sending data onto the network. And clearly there's got to be some destination address of where you're trying to get that data to. And when data is coming back to you, the destination of that data as it comes in is going to your laptop's address or your PC's address. Well, original traditional firewalls, that was the primary thing that they looked at to decide, should I drop this data or should I allow it through? And that was called a traditional firewall. So forwarding or blocking decisions were primarily based off of just those values. However, for the last several years, Cisco and other companies have come up with things called next generation firewalls. Now, next generation firewalls certainly can still make their forwarding or blocking decisions based off of addresses, just like a traditional firewall. But what makes them next generation is they have the ability to do a lot of other stuff as well. For example, they could do deep packet inspection. Now, if you're watching this video, you're probably like, what? What the heck is deep packet inspection? What that's talking about is when I put data on the wire. So when my laptop or PC puts data on the wire, clearly it's going to have a source address, which is my own address. It's going to have a destination address. There's going to be some other information in there about like what kind of data it is, maybe how far through the network it's already gone. And then you're actually going to have the data itself at the end. Okay? So deep packet inspection means that the firewall can look at any of that. Anything in there from the very first electrical signal that I put on the wire till the very last signal before I let my data go, anywhere from beginning to end, the firewall can look at that, try to match it up against something it is aware of or it's trying to look for, and then make its forwarding or blocking decision based on what it sees. It can do it based on application awareness. For example, we could have a firewall policy set up that says, okay, when a packet comes in this interface, if that packet is going to a web browser, like someone's going to www.ine.com or foxnews.com or something like that, that's okay. Let that through. But if someone's trying to do something else, like maybe play an internet-based game, maybe we have a rule in our network that says, hey, if you're on the company network, you should not do internet-based gaming. That's not what our network is for. Well, we could have our firewall saying, okay, I'm going to make the distinction between internet gaming and just regular web browsing traffic. And if I see internet gaming, I'm going to drop that. That's called application awareness. Next generation firewalls even have the ability to look at information as it's going back and forth through the ports and try to spot network attacks, what we call malicious attacks. People trying to bring down devices in your network or put a virus in your network. Next generation firewalls have the ability to do that. And they can even use outside services to do that. A lot of firewalls these days, when you hook them up to your network, they have the ability to constantly reach outside of the network. For example, a lot of Cisco next generation firewalls, when you install them, you actually purchase a subscription to a service that Cisco offers along with the firewall. And so the firewall is constantly talking back to Cisco, to servers at Cisco, saying, hey, give me information about the latest viruses out there. Give me information about the latest network attacks out there and what they look like, so I can use that information to look at the data going through me and try to determine if there's a virus or network attack going on. And because that stuff changes all the time, the firewall is in constant communication with these network devices at Cisco, getting this updated information so it can spot this type of stuff. So a next generation firewall can utilize outside services to do that. Now, an intrusion prevention system. A couple of decades ago, a firewall and an IPS were two completely separate devices. You bought them separately. They were their own separate boxes. You unplugged them. You plugged them both in, and you put them in your rack in different locations. But back in those days, a firewall, all he really did was decide to forward or block traffic based on addresses, like a traditional firewall. That's all he did. And then your intrusion protection service, your IPS box, his job was to try to spot attacks. Try to actually look at data. So data had to go through him as well. Usually you had the firewall as like, that was your connection to the internet. And then as data went through the firewall, the next device it would go through would be your IPS box. And then it would get onto your network. And the IPS was saying, okay, firewall, you've already let this traffic through. That's great. Now let me inspect it really, really deeply. Let me see if it's got some characteristics of someone trying to do some sort of an attack or something. And if the IPS spotted an attack, it could stop it. It could just kill the packet and then send a message back to you in your email or your pager somewhere. Or maybe it could just let it through, but keep some statistics if it wasn't quite sure if it was an attack or not. Well, next generation firewalls, a lot of them have IPS capabilities built right into it. So you get two services in one box. You don't really have to buy two separate boxes anymore, a firewall and an IPS. It all comes self-contained in a next generation firewall. So here's some examples of Cisco devices that serve as both firewalls and IPSs. On the lower corner there, you got the Cisco ASA 5500-X. And in the upper right corner, you've got a much more powerful Firewall 9000 series.